Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, everyone. In this video, I will demonstrate how to solve optimization problems, that is, problems that involve maxima and minimum. Now, objective of these optimization problems, at the end of this lesson, you should be able to solve optimization problems. Optimization comes from the word optimal, which means best. It is actually using the idea of finding maximum or minimum value of a certain thing to solve real-world problems. For example, minimum cost, maximum profits. This is from the business point of view where maximum profit is desired from the least or minimum investment. Okay, here, maximum return of money deposit. Let's say you have a lot of money, you want to put it in a bank. You would go to the bank which offers the maximum return of your money deposit, right? Okay, here is the minimum rate of interest. If you want to buy a car, or maybe if you want to buy a house and you want to borrow money from a bank, of course you will go to a bank which charges minimum rate of interest. Okay, here minimum amount of sugar or salt or fat. Everybody wants to look good and maintain a healthy weight, right? So you should minimize your sugar intake or maybe salt intake or fat intake. And last one here is minimum time. Let's say you wake up at 7:45 and suddenly you realize that you have a class at 8 a.m. So you need to think how to get to your class with minimum time or minimum total distance covered. Okay, before we go to our first example, here are the 5 steps to answer any optimization problems. First, find equation to maximize or minimize. Okay, this is called optimization equation. Second, you need to reduce this equation to one variable. Sometimes you can have an optimization equation that has more than one variable. So you need to reduce that to only one variable. Okay. Next step is find critical values, meaning that you have to set the first derivative to 0. Then you have to verify if the critical values that you got are maximum or minimum. Last one is you have to answer the question being asked. Let's look at a simple example first. Find the length and width of a rectangle with a perimeter of 160 meters in a maximum area. Okay, the first thing that we want to do for any optimization problem is to draw a picture of what we've been asked to find so that we can visualize what we are doing. So let's draw a rectangle first. This is a rectangle. Okay. This is rectangle. Two of the sides will be equal. So let's say this one is L, this one is L. The other two sides will also be equal and we call that W. Okay. Now we are trying to maximize the area. So the first step is to find the area equation. So area is equal to the length multiplied by the width. Okay, that is our first step. And this will be our optimization equation. This optimization equation must be in one variable before we can go ahead. So our second step, alright, our second step would be to reduce this equation to only one variable. Okay, so to do that, we can use the perimeter equation. What is the perimeter? Perimeter is the sum of all the four sides. That is L plus W plus W. And the perimeter we know from the equation, from the question, that is equal to 160. So that is equal to 2L plus 2W. Now, take 2L as a subject. So that is equal to 160 minus 2W. Now, divide each term by 2. You get L equals 80 minus W. Okay. Now, After you get L, you can substitute this L in this area equation. Okay, so the area here, area is equal to, that is, we call that A, LW, and that is equal to L is AT minus W multiplied by W. So A is actually equal to ATW minus W squared. Okay, now our A here is in one variable only. So we can go to the third step, that is to take the derivative of A. So the first step here, this is the first step, take the derivative of A, that is A prime, and that is equal to AT minus 2W, and set that to 0 to find the critical values. Now, from here, 2W is equal to 80, so W is equal to 40. Now, we get the value of W here. We want to know whether this dimension will produce a maximum area. So in that case, we need to go to the fourth step, or step number 4, that is to take the second derivative of A. Why? Because we want to know whether this W will produce the maximum area. So what is A double prime? That is minus 2. This is a negative number. Okay, this negative number implies that W equals 40 here will give maximum area. So we can say that W equals, therefore, W equals 40 will produce maximum area. Okay. Now, the question asks us to find the length and the width. Now we know the width W is equal to 40. So the length is equal to, from here, 80 minus W, and that is equal to 40 as well. Okay. Now in this case, both our W and L dimensions turn out to be the same. Okay, both are equal to 40 meters. So as we can see that the rectangle here with maximum area is actually a square, because the dimension of the width and the length both are equal, that is 40. Okay. You can try these two simple exercises before watching part 2 of optimization problems.